Hello and welcome to the VHDL Integer Data Types lecture. In this lecture, I'm going to explain the integer data type and how it's used in VHDL. In VHDL, the syntax for the integer data type is just spelling out integer, I-N-T-E-G-E-R, and it is 32-bit by default if you don't define the range. And I'll show you exactly how to define the range of your integer. And integers can represent positive and negative numbers. So by default, you have a 32-bit, but when you define the range, you can have an 8-bit or 9-bit or whatever size. The number of bits required to represent that range is how you will define your integers. And when you assign a value to an integer, there's no quotes that are needed. However, you still need to use the signal assignment. And then upon doing that, you give it just a value without any sort of quotes. And with integers, you can do things like addition, subtraction, as well as you can check for greater than, less than, similar to the signed and unsigned data types. So let's take a look and see how the integers actually work. So with the integer, we are going to add to our data type examples. We'll add to the integer, and we will create a signal that we call, we'll say signal sig I. And we're going to give it the data type integer, which is just spelled out integer. And now you want to define the range. So I could just define it to a value. So if I would just define it to a value of 0, it's going to be a 32-bit integer with a value of 0. Now, what I also can do is define the range. So I will say integer range, and then I give it the low range. I'm going to say from 0 to 255, and that's equal to a 0. So now I have an integer that would be 8 bits wide, because 0 to 255 requires 8 bits to represent that. So if I go my next line, say signal sig j is an integer, and we're going to make it the same range 0 to 255. Except we are going to give it an initial value of 5. So we have two integers. We have sig I and sig j. Sig I is equal to 0, and sig j has an initial value of 5. So we want to say our sig I is, we're going to assign it a value of 4. So when we assign the value of 4, we don't have to represent the bits or anything like that. We just give it the value of 4. It already knows the range. So the range is from 0 to 255. So the synthesizer is going to say, when I generate this sig I integer data type, I need enough bits to go from 0 to 255, and I'm going to represent it with a 4. So the next statement we're going to show is if I say sig I yields the sig j plus, we will say 5. Now we know sig j is already equal to 5, so now this statement, sig I is assigned the value of sig j plus 5, will mean that our sig I will now have the value of 10. And that is an example showing how you can use the integer data type in VHDL.